Once it's in the product form, we'll apply the product rule. Okay. So product rule says
Okay.
differentiate u and differentiate v, then you bring them together into the formula. So our u is 5x. V is what? V is e raised to power. No, let me arrange it this way. V is e raised to power x squared plus 5x. Eh? Good. Then we are going to differentiate u. So let's differentiate u. Du dx, okay, is equal to what? Is equals to 5. Now let's differentiate v too. So the v in the x will be equal to what? You see, this is e raised to power u. You understand? Where u is this? Because it's a compound function on its own. So the rule says differentiate if you want to find the derivative. Eh? The x, because it's a compound function, is going to be what? F prime of x, where f of x is what you have as the power here, eh? Times e raised to power f of x. Okay, good. So let's differentiate f of x, which is the power. When we differentiate, we get what? 2x plus 5. Okay, so that's the derivative of the power. Then times e raised to power the same function. So x squared plus 5x. Okay, and we have the derivative of v. What next? Come and apply the product rule. So per the product rule, we have dy dx will be equal to what? Will be equal to what? U dividing dx. So u is 5x. Okay. Then dividing dx is what? 2x plus 5. Okay. 2x plus 5 e raised to the power x squared plus 5x. This is the v, this is v. Okay, so sorry, this is dividing the x. So this u dividing the x plus v will be what? E raised to the power x squared plus 5x. Okay, times du dx. So du dx is what? Is 5. So from here you can simplify. This will give us what? This multiplies this, you get 10x squared, and then 5x multiplies 5. Okay, you get, of course, the e is there. So 5 multiplies 5, you get 25x, 25x. Okay, then still multiply by e raised to the power s squared plus 5x. Okay, then plus what? 5 times e raised to the power s squared plus 5x. Okay, good. So this becomes your final answer, okay, for that particular question. Good. Any other question? Any other question? I think Salusu's hand is up. Salisu,
Sir,
yes.
sir, please, the 5x,
Yeah.
it is multiplying the whole bracket. But you multiply 2x then and 5. Why didn't you multiply it by the e raised to the power s squared plus 5e?
But it's still multiplying. The yeast is still multiplying here. It's still there.
Okay,
It's still multiplying everything.
okay. Thank you, sir.
Okay. Yeah, I think we're okay here. So let's go back to the link function. continue from there. Daniel, don't sleep. Oh. Come again. Some questions after class. Kenda.
Okay, sir.
Yes.
When you differentiate them, the ln 5x plus 2,
Yeah.
I just didn't get how you arrive at 5.
When you differentiate 5x,
I didn't get that.
anytime you differentiate x,
Yes, sir.
you get 1. Okay? The derivative of x
Okay.
is 1. I just explained
Okay.
that somewhere here. So take notes. So it will be 5 times 1, which will be 1.
Okay. It's clear, sir. Thank you.
You're welcome. Okay. I want to finish the target for today and then use maybe the last 20 minutes for discussions on examinations. Okay. So let's not mix questions on exams with what I'm doing for today. Okay, so that is for logarithmic function. Now, the next thing we want to look at will be the concept of the chain rule. Okay. For chain rule, we are talking about two functions, y and, or let me put it this way. Let's say you have a function like let's say you have a function like y is equals to 5. Let me just make it simple. So cos, okay, 2x plus 1. When you look at this, clearly you can see that this is trig function, and then this is linear function. Okay, so it's a function of a function, a composite function, right? So what happens is usually we let one of the functions or the inner function be equal to what? U. Okay, so if you let u be equal to 2x plus 1, then it means that the function y will become what? Cos u. Okay, good. Then, which means that y is a function of u and u is a function of x. Okay, so the chain rule helps us to do that differentiation. So the y dx can also be expressed as what? Dy du times du dx. Okay, so when you look at it technically, this cancels out this, right? Then you come back to the y dx. Okay, so what we need to do is you have to differentiate y with respect to u here. So that will imply we differentiate y prime with respect to u, or let me do it this way. Dy du will be equal to what? When you differentiate cos, you get what? Negative sine. So you get minus sine u. Okay. Then next, you also have to differentiate u with respect to x. Okay. So we are going to differentiate u with respect to x. So the u dx will be what? Will be equal to what? 2. Okay. Good. So all you do next is come and multiply the dy du by the du dx. So this will be negative sine u, okay, times what? Times 2, okay? Then once you are done, you replace the u with the actual value. So this will be sine of what? 2x plus 1. Okay, so that is how we do the differentiation for a chain function. Okay, good. Let's take another example, then I'll take your questions. So example 2, if you have y, which is what? Y, which is x cubed minus 5, all raised to the power, say 7. Okay, then we will let u be equal to what? S cubed. Okay, s cubed minus what? 5. If we do that, then it means that y will become what? Y will become u raised to the power what? 7. Okay, y becomes u raised to the power 7. Okay, good. So like we did in the first case, you first differentiate y with respect to u. Okay, so dy with respect to du will give us what? 7 u raised to the power 6. Okay, and then we differentiate u also with respect to what? X. That will give us what? 3x squared. Okay, then after you are done, you come and do the multiplication. So dy dx will be equal to the dy du, which is what? 7 u raised to the power 6 times what? Times du dx, which is what? 3x squared. Okay, then you can comfortably replace your u with the original value here. So that will give us 21 x squared times, then I'm bringing the u, so that will be what? X raised to the power 3 minus 5, all raised to the power 6, because it's u raised to the power 6. Okay, so look at it, and then let me take 2 or 3 questions, and let's move on. Okay, so clearly this kind of examples, we've seen them in class already, but we did chain rule the other time. Okay, good. Now yes, I can see some hands up. Wait a minute. Yeah, so Desmond, your hand is up. Yes.
Please, can you scroll up a bit?
Come again.
I wanted to. I said, please, can you scroll up a bit?
Okay.
I can't see, so I want you to scroll up. I want you written at the down part. I can't see, so I want you to scroll up.
Okay, noted. Um, Matthew. Or Daniel Darko. Daniel Darko, let me hear from you.
Hello, sir. Hello, sir.
Yes, I'm listening.
So please, can you go over the second example again, please, sir?
Can we go over?
The second example.
Yeah, so second example is a compound um, kind of function, okay? So we let what is inside the bracket be equal to, let x cubed minus 5 be equal to u, which means that y will be u raised to the power 7. And then the next objective is differentiate u and differentiate y. When you are done, multiply the derivative of u with the derivative of y. I think we did that a number of times in class last week. So that shouldn't be a problem. Okay. Let me hear from Jabil Muhammad.
Hello, sir.
Yeah, Jabil.
Sir, please, I want to ask for the question one, you asked of cos 2s plus 1. So, Abi, you can use the product rule to solve this kind of question because the cos and the function were multiplying.
No, they are not multiplying. You see, the 2x plus y is inside the cos. It is not multiplying it. You see, it's in bracket within the cos function. So it has replaced x inside of the cos. You understand?
Okay, sir.
So it's not
So, sir, please, that's why I use the chain rule.
exactly because it's inside another function.
Okay.
So anytime you have a function inside another function, we say it's a compound function.
Okay, sir.
Okay, can I take one more question? Matthew and Sean. Matthew. Okay, let me hear from Godwin.
Okay, sir.
Yes.
Please, with the dydx, your final solution. Please,
Yes.
I'm a bit confused. The 7u raised to the power 6
You are just
times
multiplying.
3x raised to the power.
Hello.
Okay.
It's just a
Sure.
multiplication. That's all. So if you've managed to find the y du and you found the y dx, it's just a matter of multiplication. I don't think multiplication should be
Okay, sir.
just multiply. That's all. Pascal.
So, but what of the
What of which one?
hello?
Pascal, hold on. Let me finish with Godwin first. Godwin, you said what of? Godwin, come back. I've unmuted you.
Okay, so the x raised to the power 3 minus 5 into bracket 6. Is it with the question itself, bringing it
Is
there,
it with
or
what?
like bringing the question as a whole, placing into the final answer?
No. This is also a compound function on its own. So you will let what is inside the bracket be equal to u. Okay.
Okay.
Yes.
Okay.
So let me just take you back to the board. I don't know why you are still getting confused with this. It's just a compound function. So follow the rules for compound functions. Just follow
Okay, sir.
the rule for compound function is different from that for exponential function. So don't mix them up.
Okay, sir. Thank you. Okay, sir. Okay.
Yeah, so you have the function as x raised to the power 3 plus, let's say 2 raised to the power 7. This is one function, okay, and then the outside function to is s raised to the power 7. So you will let this be equal to u, like we said. So it means that y will now be u raised to the power 7, whereas u is what is another function, which is what s cubed plus 2. So the rule is differentiate the two. For chain rule, just differentiate the two and multiply. That's the rule. So differentiate y with respect to u. So dy du, okay, will be what? 7u raised to the power 6. And then du dx will be, du dx is going to be what? 3x squared. Okay. Then after that, multiply the two to get your dy dx. So dy dx will be what? Will be this one times this one. That's the stage I was saying, just multiply. So 7u raised to the power 6 times what? 3x squared. And that simplifies to be 21 u raised to the power 6 x squared. Okay. But we all know that u is x cubed plus 2. So that becomes 21, okay, x cubed plus 2 all raised to the power 6. Then you bring your x squared here, okay? And that is a derivative. You can choose to expand or simplify, but essentially this is the answer. Yeah, Godwin, your hand is up. Yeah, Godwin, your hand is up. Okay, I think he's lower the hand. Moses Prince.
Yes, sir. Good morning.
Moses, speak up, please.
Sir. Hello, sir.
Speak up.
Sir,
I'm not hearing
please.
you.
Sir.
Yes.
Hello.
Yes, Moses.
Hello, sir.
Yes,
Sir, can you hear me now?
I can hear you.
Sir, I wanted to ask about the other video, the other example, the course example.
Yes.
Please, you see, you said the U is inside the course. So I wanted to ask if, let's say, you have an equation like x squared times 2x plus 4. Are you going to use the product rule or you use the
S
chain
squared
rule?
plus, give me the equation. So y is equals to s squared
X squared plus 2 times 2x plus 4.
times 2x
2x plus 4.
plus 4
Like the 2x plus 4 will be in the bracket.
in bracket like this.
Yes.
But that is
Yes,
far
sir.
different from the cost situation. Let me demonstrate the cost situation well for you. So cost
Okay.
situation is like this. Cost itself is a function, and the function is always in this form, cos x. This is how cost function should look like. So if you
Okay.
see in the place of x, something else is there, then that is another function inside in place of the x. So if you see something like cos into bracket 5x plus 1, you see,
Okay,
this
sir.
is not the normal cost function. The normal cost function is cos x. So if you see something else in place of the x, then it means that that one itself is another function within the x. It has come to replace what? Within the cost, it has come to replace the x in the cost function.
Okay.
But in this situation, this one like this, you can just expand. This is x squared plus 4x plus 8. And then you just differentiate. It's straightforward.
Okay, sir.
And this one is straightforward. Okay.
All right, thank you.
Okay. I think the questions are okay now. We can proceed from here.
Y is
7, okay, or some. Now, let's also look at the higher derivatives, okay? So listen to that carefully. Let me just explain with an example. If I have y is equal to, let's say 7x raised to the power 5, and I ask you to find the first derivative, okay? That will be what? 35. So let me take my time and explain this side. We are saying that we can have higher derivatives, okay? Higher derivatives mean, you see, all along what we have been doing is dy, we've been finding dy dx, okay? Good, but we have second, this one is a first order differential equation, or, oh, sorry, it's a first derivative, okay? Now we can have a second derivative, third derivative, fourth derivative, okay? Which is written as what? The squared y, so second derivative is the squared y, the x squared. Okay, third derivative will be the cube y, the x cube, and so on and so forth. Okay, so in shorthand, we can write this is y prime, this is y prime prime, this is y prime prime prime. Okay, this y prime prime prime. So for this question here, which is y is equals to 7x raised to the power 5. If I ask you to find the first derivative, but it's just a matter of the exponents coming down to multiply. So we get 35 s raised to the power 4. Okay. For second derivative, the 4 will also come and multiply. Okay, which will give us 140. Okay, s raised to the power 3. Okay. Then for the next derivative, means you are differentiating it again and again and again. So next derivative, we come and multiply 140 by 3. We'll get what? 420. Okay, s raised to the power 2. Then if I want the fourth derivative, 4, it means I'll differentiate again. So s2 comes forward. We'll have 840 x. Okay, sit the fifth derivative, we'll get 840. Okay, so y raised to the power 5, okay, will just be 840, 840. And when we differentiate again, we'll get 0 because the fifth derivative gave us a constant, okay, which is not a continuous function. Good. So this is what we mean by higher derivatives, first derivative, second derivative, third derivative. So if I ask you to find the second derivative, it means you differentiate the first time and differentiate again with the same, with respect to the same variable. Okay, good. Can I have some questions if there are any on this point? Any questions on higher derivatives? So let's try another example. Okay, just in case you are not too okay. So let's say we have x raised to the power, okay, 4x cubed plus 2. And I ask you to find the second derivative. Find second derivative, y prime prime, okay? Usually write y prime prime like this. So that gives us what? Y prime will be what? When you differentiate, you get 12x squared. Then y prime prime is going to be what? 24
Maybe I put 1.6,
going to be
1.6.
24x. Okay, and that is the answer.
Okay.
If I ask you to find the derivative, means we will differentiate
You
twice.
say, no, you say it's 1.5.
Okay, basically that's
See,
what
the
that
from
is.
outside, you open one more.
Okay. So if there's any question, you can raise your hand on this point. Any question? Yes. Yeah. Abraham.
Sir,
Yes.
this you said 4s raised to power 3 plus 2. So I don't know the place that you place the 2.
You don't know the place that I did what?
The place that you put the 2.
Any other question before we end the class for today?